Algebra 1, Chapter 7, Section 2, Multiplication of powers with the same base. We want to circle the base in each expression. Now, each of these expressions have two parts, a base and an exponent. So to circle the base, we want to circle the 5. We want to circle the -3, and we want to circle the n. So if a student writes an expression with an exponent 4 and base 3, would it be 4 to the third power? No. Your base is 3. So base 3 makes it a 3 here. Your exponent is 4. So looking at our vocabulary builder, our main idea is repeated multiplication. And that refers to the same number being used as a factor more than once. So if we take this problem, 7 times 7 times 7, and we want to write it as a base and an exponent, our base would be 7 and our exponent would be 3. Here our base is -4, and we have it 1, 2, 3, 4, 5, 6, 7, 8 times. So our base would be -4 and our exponent would be 8. Now notice in this one, the negative is being multiplied each time as well. So I'm going to use parentheses so that we know that what's being raised to the 8 is the entirety of -4. Now let's do the opposite and write each expression as repeated multiplication. So here we have 2, but we have 2 5 times. So 2 times 2 times 2 times 2 times 2. Problem number 8, notice the -3 is being repeated. And it's being repeated 2 times because your exponent's 2, so it refers to 2 times. Here we have 1/2, and it's being repeated 3 times because that's what our exponent says. Our exponent of 3 says do it 3 times. This is not repeated multiplication. This is not repeated multiplication. This is C repeated 17 times. This is 27 times y times y times y. Now the 3 only applies to the y. So this is 27 times y times y times y. The 27 is not being repeated. When exponents have like bases and they're being multiplied, we can add the exponents. So let's look here what's happening. 2 squared, it's 2 times 2. 2 cubed is 2 times 2 times 2. So here we have 2 squared, and here we have 2 cubed. So obviously if you count them, we get 1, 2, 3, 4, 5 to the 5th power. We can also get that by doing 2 to the 2 plus 3, which you will also see is 2 to the 5th power. So when multiplying same bases, you can add the exponents. To repeat what I just said, so if we have a to an exponent m and a to an exponent n, to find the solution or to simplify it, we're going to add the exponents. You see 2 examples up here. So let's go ahead and compare these. So for number 11, we have 6 to the 5th, and here we have 6 to the 6 minus 4. Well, 6 minus 4 is 2. So obviously 6 to the 5th is larger. So that's my answer. For 12, we have 8. 2 plus 9 is 11. And 8, 12 minus 1 is 11. So that one's equal. 3 to the first and 3 to the 0. Well, 3 to the first is 3. And anything raised to 0 power is, 1. So obviously 3 is larger. 1 to the 7th and 1 to the 0. Well, 1 to the 7th is 1 times 1 times 1 times 1 times 1 times 1 times 1, which is 1. And anything raised to the 0 power is 1. So this is equals. Looking at problem number 1, we have 3 problems across the top. We're going to solve, and we're going to solve them below. And we need to remember that when you multiply powers with the same base, having the same base is very important, you add the exponents. So in this first problem, which is problem 16 down here, we have the same base. The base is 8. So we're going to add the exponents. So it's going to be 3 plus 6. 3 plus 6 is 9. So my solution is 8 to the 9th power. For problem 17, that's the second problem, again we're going to add the exponents. So our first exponent is -3, and our second exponent is -8. So -3 minus 8, which is -11. That's our solution. In our third problem, again, we have the same bases. So our base will be 9, and we're going to add the exponents. So -3 plus 2 is -1. -1 plus 6 is 5. So our answer is 9 to the 5th power. Sometimes our problems become a bit more complex. So to simplify expressions that are a bit more complex, we need to do some grouping. Now, we have two properties we know that do grouping, commutative and associative. Commutative is when you change the order of something. Associative is when you move the groups, when you change the groups or what's in parentheses. So to get from here to here, I changed the order of x to the 9 and 3x squared. So I use the commutative property. Now in the next problem, I grouped the 5 and the 3. That's associative. And then I multiply the 5 and the 3, so it's multiplication. Now I notice that I have the same bases, so I can combine these. But to combine these, I need to know what exponent this is. So I'm going to write my x as x to the first power, because I know that any x set in there is x to the first power, unless otherwise noted. Same base, I add the exponents, and then I simplify. Now, exponents can be rational numbers. When they're rational numbers, they show up as fractions occasionally. Using a fraction is the same as using a radical. So using 1/2 of something, let's say 4 to the 1/2 power, is the same as taking the square root of 4. An example of multiplying a number by itself twice is multiplying 6 by the same number, 6. Thus, 6 times 6 is 36. We want to find the number that's when it's multiplied 4 times, so x times x times x times x, it will equal 16. Well, if we have 4 x's there, it's x to the 4th power equals 16. Well, the only one that would work would be 2. 2 times 2 times 2 times 2, which equals 2 to the 4th power, now that we're using exponents, equals 16. Now, how we write this is the 4th root of 16 is 2. Okay. Now, using radicals, we see that 16 to the 4th power has a 4 in the denominator of the exponent. So it's asking what number multiplied by itself 4 times equals 16. So 2 times 2 times 2 times 2 equals 16. So 16 to the 1/4, which another way of writing this, where this 4 is called an index, is 2. Note that this and this is the same thing, just written two different ways. This is the last slide we'll do together. After this is your check understanding. For 26, we're going to circle the expression that shows the correct way to rewrite this expression. The expression is up here. We have b to the 2/3, c to the 2/3, b to the 4/9, c to the 9/10. Well, we're going to use the associative property and the commutative property to reorganize these and group the same base together. So this problem has the same base together, but when they grouped it, this is correct, but the second one is not the same. The exponent got changed. So this is not right. Looking at the last one, they did not group the same bases. The bases are different. So that's not right. Looking at this middle one, our bases are the same. Let's see, we used b to the 2/3, b to the 4/9, c to the 2/3, c to the 9/10. So that one is correct. And then a little review on fractions. So when adding fractions with different bases, remember that we have to make the same base. So this, to become this 9, we're going to multiply by 3. So it's going to be 6/3 instead of 2/9. So we'll have 10/9 as our fraction. And then here we're going to make it 20/30. We're going to make it 27 over 30, same base. So I should have 47 over 30 when I add the numerators. And last but not least, we're going to go up to this problem and we're going to use our rewritten form. And if you look, in the two previous problems, we've done the fraction part of this already. So this will be b to the 10 ninths, and then it'll be c to the 47 30ths, because when we add them, they got to have common denominator. Remember, if you have any questions, bring them to class tomorrow.